To build a permanent settlement on Mars, we will have a three-phase plan. Phase 1: Expedition and Exploration. In this phase, we will explore the surface of Mars and study the environment. We will also look for important locations of useful resources and carry out various experiments. Phase 2: Development and Transfer of Technology from Earth to Mars. In this phase, we will gather resources and transfer technology by building infrastructure. Phase 3: Permanent Settlement. This phase will be a long-term plan. During this phase, we will gradually build a large-scale structure for a large population to live. In this video, the concepts will be explained about the architectural designs of different phases for 1 million settlement on Mars. Phase 1 is an experimental project, which has to be compact and mobile, so that the astronauts can have a better experience when exploring the surface of Mars. Astronauts sent on such missions to Mars will have to live there a minimum of 1 year. So all the function has to be integrated into a limited space. Keeping all of these considerations in mind, the concept of this design is inspired by Leonardo da Vinci's Vitruvian Man, to make it ergonomically precise. Various forms have been developed from the five-sided shape guided by 5 points of the man's head, palms, and feet. The base of the shape is then extended to provide extra space. The form of the typical block has been tapered on one side, and widened on the other, so that the blocks can be compacted during transportation through spaceship. As for the protection from radiation and micrometeor impact, caverns can be built in small craters by using RASER. RASER is a rover developed by NASA to dig the Martian surface. The Forms of Mars Habitat Vehicle module is designed in such a way that it can be used multiple other purposes in the future. In Phase 2, our aim is to transfer technology from Earth to Mars, assuming that there will be some sort of human presence already existing there. Since no advanced infrastructure will be available at that time, the build process should be as simple as possible for the astronaut. To achieve such a solution in this design, the built form is generated from the site. The idea is to create a form from the curvature of the crater, so the forms can easily be placed and fitted in the crater. The round shape of the form makes it easier to roll and move around places. The plan is to send prefabricated parts and modules from the Earth, and the astronauts will just install them in place. This will make the project more feasible, since no sophisticated instrument will be needed. As for the life support system, a rocker will be sent from Earth, that will land on the crater, integrated with all necessary instruments for life, around which the modules and the parts will be installed. A layout plan will be projected over the site from the rocket using a laser to guide the astronauts to carry out their work. The rocket will also work as the powerhouse of this complex, by collecting thermal energy from the surrounding mirrors, that will be placed around the site, and distribute heat in the complex. Similar to the Phase 1 project, since the habitat will be built underground, the inhabitant will be protected from the radiation and micrometeor strike. Also, due to the conical cylindrical shape of the form, it allows us to keep it compact during transportation. Phase 3 has to be designed for 1 million population to live. This will become the first civilization beyond Earth. This will be another giant landmark in the history of mankind, which reminds us of the famous quote said by Neil Armstrong, "That's one small step for a man, one giant leap for mankind." The design is inspired by this wisdom. 3 great towers will be erected to complement the achievement done by the first 3 astronauts in the famous moon landing. The towers will be named after them, in their honor. The vertical approach of design gives better advantages over the horizontal approach. A tall building means the overall site area will be reduced, thus reducing the risk of micrometeor strikes. The tallest tower will have 80 floors. Each floor will be 50 meters in height, to create a natural environment suitable for life. The floors will have a thickness of 15 meters, which will include structural elements, a water recycling system, and a massive layer of soil. These layers of masses and floors will help in preventing radiation. The external condition of Mars is not suitable for life, so less external activity is recommended. Since this complex will have an enclosed system with all the necessary facilities, the residents living there don't have to go out, except for collecting resources or in emergency cases. Inside the complex area, the residents can enjoy a large enough space and travel freely without any spacesuit. Because of these reasons, there will be a better impact on social interaction and people can have an improved lifestyle.